Okay, this video is going to explain about how to draw up placing balls in tapers to measure them when you're cutting them. It's going to be based heavily on 7.125 degrees per side, which is the grinding wheel hub taper. See that in there? Okay, now this is very common. It's for Herrig surface grinders, and it's 1 inch on the big end. That's how they're defined, is the size of the big end of the taper. And so it's 1 inch. Okay, so this is a 1 inch ball, and it goes like that. And it just so happens that tangency, it does hit just barely at the very top. And so I'll show you that. But it's going to be based on that, this video. It's not going to be based on teaching trigonometry from A to Z or teaching how to use CAD/CAM. Because if you have CAD/CAM, after you see how to do it, you will be able to go and do it. So in the video, I can't teach every stroke, every keystroke, every trigonometry, angle, sine and cosine, so on and so forth. But anyway, there you go. So I have to stop filming, otherwise the camera won't focus on the screen. I'll show two methods that are how to place a sphere in a taper, in other words, the ball that you're going to use to check the taper while you're making it, and also how to do roll pins. How do you place the roll pin on the geometry so that then you can click and tell what is the, how do you measure. Okay, so for the to put the sphere in a taper, now here it is. Okay, see there's the physical taper itself created in the solid, but we're not going to use that. I just wanted to show you that. See the taper? That's the 7.125 for a Herrig surface grinder and most surface grinders in a shop. Okay, but we're not going to use that. What you do is you just draw it in 2D. You draw it in 2D. Okay, like this. And here again, it assumes that, for instance, each click to produce these lines, produce a center line and then tell it to rotate it over 7.125 and then over the other way 7.125 to produce this cone. It's not the scope of this video for me to explain everything like that, or it'd be hours long. Okay, now how do you place a sphere down in there? Now the top of this is 1 inch. Up there, that's 1 inch. In other words, that hub you saw with the ball sitting on top of it, that's what this is. That is what it is. I did bring it down to a point, and that is the way that people do it with their drawings. You just bring the cone to a point. Okay, so if you want to place a 1 inch ball in there, you just offset the lines by ½ inch. So X form offset 0.5. Okay, and you click on the lines, offset, offset. Now see where they coincide up there? Right there, right where they coincide. Okay, so I go a circle, a diameter of 1 inch, and click right there at the intersection, and look at what we have there. The perfect. Let me change. Let me change the color so you can see it. Damn. Sorry about that. Okay, so there you go. There you go. It's the tangency is down below. It's right on the chamfer of the hub. So it is down there. See where that little mark is? See the tangency of where it's touching? It is down in there. And so once you place the ball, now I'm going to do a 3/4 also. Once you place the ball like that, they use common methods like what you already know to use. For instance, here's your surface right there, where you're turning the taper, and there's you faced off. And so, in other words, I don't need to explain to machinists how to measure from here to the top of the ball. Okay, I assume you know how to do that. Now with the 3/4, the ball's going to be down in there. And so what you'd be doing is you'd be taking a depth mic and you'd be micing down into the top of the ball. Okay, so I'm assuming that you know how to do that. So let's delete what I just did. Now I'm going to do the same thing for a 3/4 ball, which will be down in the taper. Okay, create arc, circle center point, or excuse me, X-form, offset. Okay, now it's going to be a 3/4 ball, so the offset is 375.375. Okay, offset, offset. See where they coincide? Okay. Now let's create the ball. Diameter 0.750, and right there at the central point, and look at what we have there. See there? There it is, perfect. Okay, so to make your taper exactly to the 10th on the lathe or the mill, wherever you're making it, it's just the distance from the top of the ball to the top. Okay, now I'm going to show the create fillet method to do the same thing. Okay, so let's delete what we just did. Okay, now this is also for doing roll pins. A lot of people don't know how to do roll pins on the geometry of their CAD system. Okay, create fillet entities. Okay, so first thing I'm going to do is a 3/4 inch ball. I won't do the 1 inch, but it will produce the ball just like I showed you at the start. It will do the same thing. So let's do the 3/4. Okay, so 3/4, 0.375, half of 3/4. Now let's create our fillet. Okay, create the fillet. There you go. Except I don't want it to trim it. So there. Okay, and now I want to put the ball there so you see the hole. Now that would be good enough for my numbers to depth mic or whatever, but instead let's put the ball there so that you physically have the satisfaction of seeing the ball. Okay, now this is create fillet. So you just go edit, trim break, close arc. Click on it, enter, there's your ball. See there? And it's placed perfectly, automatically tangent with the sides of your taper. And so the distance to depth mic down there, and your taper will be right on to the millionth, as close as you can measure, is analyze distance, top of the ball to here. And that distance is 0.6017. So if you physically do this and take a 3/4 inch ball and put it in there, you can actually make this taper, and that 0.6017 is exactly accurate to the 10th. You will produce that exact taper. Okay, now let's do a roll pin, because this is closely related. Oops. This is how to do roll pins. You make them as a fillet. So I'm going to go down to the bottom here as if this was a pocket with angled walls. Let's say it has angled walls. Okay, they're straight up and down, but it doesn't matter. And so create, fillet, entities. Okay, and it's a 1/4 inch roll pin, so I'm going to go 0.125 radius. And you just do the same thing. Click, 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 click. Okay, and there you go. And so let's make them circles so that it will be easy to visualize instead of having to do the math. Trim break, close arc, click, click, enter. There's your roll pins. And so your gauge blocks in between here to get the thing perfect. It's analyze distance from there to there. So your gauge blocks 2.5. It just so happens that it would be exactly a 2-inch and a half inch. And when your gauge blocks measure that, well, your walls are exactly there. So in other words, I've showed the basic concept, but now your CAD system and the trigonometry, the intent was not to teach trigonometry and machining 101 and CAD-CAM 101 from first grade on. That was not the point of this video. But to place a ball in there, that is how you measure tapers. To place the ball in there, you have to know how to place that ball in there. Okay, and that's what I've done. That's what I've showed you. I've used two methods. So you offset. If this is 3/4, then you just simply offset half of it. Offset, offset, and snap the ball to the intersection of the lines, and there you go. Okay, that's it. So I hurried this up and I made this video half as long as the first one that rambled too much. But it's very hard to show a lot of complex stuff and do it in just a few seconds.